to the last learning unit in the chapter PV Systems Components. In this learning unit, we'll cover the topic of lightning and surge protection. Lightning strikes are rare, but they can severely damage a PV system and its components. In addition to only direct lightning strikes represent a risk, but also indirect ones. A direct lightning strike is lightning that strikes directly into the PV system or the house. The probability of such a direct lightning strike is extremely low. In addition to the location, it depends, among others, on the height of the building. The higher the building, the greater the probability. As soon as higher points, for example a church tower or big trees, are nearby, the risk is reduced. We speak of an indirect lightning strike when lightning strikes in the immediate vicinity. Such a lightning strike can lead to overvoltages in extended conductor loops due to induction. In addition, strikes in or near supply lines can also lead to a voltage increase in the network. This is the case, for example, when lightning strikes an overhead power line, a radio mast or a street light. The very high voltage generated by these means is passed on via cables lying in the ground until it hits a fuse box or an electrical device, for example the inverter of a solar power system. This means that even lightning that strikes near a building can cause significant damage. The range at which damage can be expected is up to 500 meters. Thus, the probability of indirect lightning damage is significantly higher than that of direct lightning damage. Buildings and objects can be protected against the consequences of both direct and indirect lightning strikes. In many countries, there are legal regulations that specify in which cases lightning protection must be provided. In Germany, for example, a lightning protection system is mandatory for public buildings above a height of 20 meters or for particularly exposed buildings. Let's first take a look at what a protection system against direct lightning strikes can look like. This is also referred to as external lightning protection. Such a lightning protection system usually consists of several lightning rods, which transmit the lightning current in the event of a direct strike via several current conductors into the ground. The planning and implementation of an external lightning protection system is carried out by lightning protection specialists. First, various risk factors are used to determine which lightning protection class is required or desired for the building. There are a total of 4 lightning protection classes, with protection system in class 1 offering the highest level of protection. When planning the lightning protection system, the rolling sphere method is usually used. Here, the area at risk from lightning is defined as a sphere. The radius of the sphere is determined by the selected lightning protection class and is between 20 and 60 meters. This sphere is then rolled over the model of the object to be protected. All points of the contact between the sphere and the building are at risk of lightning strikes and are then protected by lightning rods. The higher the lightning protection class, the smaller the lightning protection sphere radius and the closer the lightning rods must be. From the lightning rods, the lightning currents are discharged via solid copper conductors with a cross-section of at least 50 millimeters square. These conductors lead into the ground. But is there an increased lightning risk if PV systems are installed at or on top of a building? The answer is no. The installation of a PV system on top of a building does not increase the risk of a lightning strike. Therefore, when building a PV system, there is no obligation to install a lightning protection system. However, if the building on which the photovoltaic system is installed already has a lightning protection system, this protection must not be worsened by the photovoltaic system. The photovoltaic system must therefore fit into the lightning protection system. In order to prevent a direct lightning strike into the PV system, all system components, that is the PV modules, the mounting system and all cables, must be completely within the protection range of the lightning protection system. To prevent current flashover from the lines of the lightning protection system to the parts of the PV system, a certain separation distance must be maintained everywhere. This distance is approximately 0.5 to 1 meter. An exact calculation is made by a lightning protection specialist. In the example shown here, the separation distance was observed. It is obvious, however, that this means that a large part of the available roof area cannot be used. In practice, however, it often happens that the necessary separation distance is not maintained when building a PV system. Reasons can be, for example, a very small roof area or lightning conductors running across the roof. In this case, the PV modules or the mounting frames are connected to the lightning protection system at several points in order to prevent a flashover from the lightning conductors to the PV system. As a result, a lightning current splits via the mounting rack and the lightning conductors and is discharged to the ground. External lightning protection can protect a building from a direct lightning strike. However, external lightning protection does not prevent high voltages from building up between the lightning protection system and the metallic objects inside the building in the event of a lightning strike. To prevent this, external lightning protection must be necessarily supplemented by internal lightning protection. In addition, high voltages can build up even without external lightning protection, for example, in the event of an indirect lightning strike to a supply line or the immediate surroundings. For this reason, internal lightning protection is now always mandatory in Germany for newly installed PV systems, even if there is no external lightning protection. In other countries, the regulations may differ from those in Germany. The most important measure of the internal lightning protection is the potential equalization. In every building there is an equipotential bonding rail, which is connected to the ground, for example via a foundation earth electrode. All metallic housings of electrical devices, as well as all metallic lines, including gas, heating or telephone lines, are connected to the equipotential bonding rail. For a PV system, this means that the metallic mounting system and the metallic housing of the inverter must be connected to the equipotential bonding rail. This ensures that all connected objects as well as the building are at common electrical potential. This prevents the occurrence of unwanted voltages between different points within a building. Without grounding, such voltage would discharge if touched by a person, or lead to a formation of sparks or arcs, which can ultimately be triggers for fires. Lightning currents that are coupled in via grounded lines can be discharged directly into the ground through the equipotential bonding rail. However, the active power lines cannot be grounded, since this would lead to a short circuit. For these conductors, so-called surge protection devices, or SPDs, are used, which briefly perform grounding in the event of an overvoltage. During normal operation, SPDs act as insulators. However, in the event of an overvoltage, for example as a result of a lightning strike, they become conductive and the overvoltage can be discharged to the earth. The circuit behind it is then thus protected from overvoltage. Surge protection devices must be able to dissipate very high surge currents in a short time so that overvoltage in the circuit behind them are reduced. However, there is always a remaining residual voltage. The protection level of a surge protection device indicates how far the overvoltage can be reduced. The remaining residual voltage that still occurs despite a surge protection device is called the protection level. Depending on the discharge capacity and protection level, a distinction is made between three classes of surge protection devices. Type 1 surge protection devices have the highest surge current carrying capacity. They are designed to withstand the load of a direct lightning strike and are used where partial lightning currents can flow not only through the external lightning protection system but also through electrical lines or cables. If the protection level from a type 1 surge protection device is higher than the electrical strength of the lines to be protected, type 2 SPD must be connected after it. Class 2 SPDs represent the so-called medium protection. They are designed for surge currents that can be expected from indirect lightning strikes. Since the peak values and duration of surge from indirect lightning strikes are far less than those from direct lightning strikes, type 2 devices have a lower protection level than type 1 devices. Finally, there is class 3, the fine protection. The SPDs have the lowest protection level. They protect sensitive electronic end devices, for example a PC or a TV, from surges caused by distance lightning strikes. But which surge protection device do we need in our PV system? Just as with external lightning protection, the rules and regulations for the use of surge protection devices vary greatly from country to country. In Germany, this issue is regulated in various standards. A total of 3 cases can be distinguished. Let's first look at the simplest case, a roof without external lightning protection. Here, a type 2 SPD is mandatory at the distribution panel. If this has not yet been installed, it must be done when building a PV system. In addition, a type 2 SPD on the DC side of the inverter is recommended. Here, each MPP input of the inverter must be protected by a separate SPD. So for inverters with multiple MPP trackers, multiple SPDs are also needed on the DC side. In addition, surge protection devices are required for data and communication lines if such lines are laid to monitor the system. If the cable length exceeds 10 meters on the DC or AC side, additional SPDs must be planned on the corresponding site. Now let's look at a building with existing external lightning protection. In the best case, the separation distance from the lightning protection system can be maintained. In this case, only the requirement for a surge protection at the distribution panel changes. In the event of a direct lightning strike to the external lightning protection system, high partial lightning currents are to be expected in the distribution panel, so a type 1 SPD must be planned at this point. At all other points, a type 2 SPD is sufficient. The situation is different if the separation distance cannot be maintained. In this case, as we have already seen, the PV systems are connected directly to the external lightning protection. Due to this connection, in the event of a lightning strike, it must be expected that partial lightning currents will flow off via the DC lines of the PV systems. Therefore, type 1 SPDs must be used throughout the system here. While the cost of a type 1 SPD for AC is manageable, type 1 DC SPDs quickly reach sums that make a PV system unprofitable. It is therefore essential to check whether adapting the external lightning protection system is the more economical solution. In addition to the measures already presented, lightning protection should also be considered when wiring the modules. Special care should be taken to ensure that no large conductor loops are created. In the case shown here, there is a conductor loop of many square meters in which a high voltage would be induced in the event of an indirect lightning strike. If the modules of the upper row are mounted upside down, instead the cables can run much closer together. This allows the area of the conductor loop to be significantly reduced. Let's summarize this unit. A PV system can be damaged by both direct lightning strikes and indirect strikes. The probability of a lightning strike to a building is not increased by a PV system. An external lightning protection system protects against direct strikes using a system of interception rods. An internal lightning protection system uses surge protection devices to protect against indirect lightning. For buildings with an external lightning protection system, the separation distance should be maintained. Otherwise, the PV system must be integrated into the lightning protection system, and expensive Class 1 surge protection devices must be installed on the DC and AC sides of the inverter. I thank you for your attention.